Welcome back. Today we're going to look at references. So references were created in order to streamline the process of passing a value through a parameter by reference. And rather than using pointers, a parameter will use a different syntax. So if we were passing ref_sum and ref_sub as pointers, we would use an asterisk. But instead of the asterisk, when you're passing by reference, just use an ampersand sign. When you call a function defined this way, and you realize this is the function prototype, and this is what would be also in the function definition, would be the ampersands. Notice that here, we don't need to use the ampersand sign to say we're passing the address of summation and subtraction in the function call. So this is a function call. This would be what would be typically in main. And what will happen is C++, recognizing that this parameter is a reference, will just implicitly pass in the address rather than having you explicitly designate as an address with an ampersand. So this is much easier in practice to use, and it works essentially the same way. The reference parameters employ the ampersand sign in the function definition as opposed to the function call, like when you use pointers. The ampersand operator is used in the function prototype and the function header line. And then when you make a call, you don't have to worry about having anything, any special symbology, because C++ will figure out what to pass in. So here's an example of using pointers. We have this math function, and we have in the function prototype for math, PTR_sum and PTR_sub are defined as pointers using the asterisk. So PTR_sum is a pointer to a double. PTR_sub is a pointer to a double. Similarly, in the function definition down here, we can see, it has the same definition as a function prototype. And again, PTR_sum and sub are pointers to a double. And then when we want to use those parameters in our function, notice that what we're doing is we have to dereference the pointer. We have to use an asterisk also in the function as well in order to dereference it so that num1 and plus num2 doesn't go into PTR_sum. It goes into the address pointed to by PTR_sum, which would be up here. Now, when we're calling in the calling function for a pointer, notice that we have ampersand signs, and in this position, this ampersand sign really means pass in the address of summation and the address of subtraction, so that when we dereference the pointers in the functions, the values will go into these variables that were defined in main. So that's just a review of pointers. We learned that the last part of the chapter. Let's look at what it looks like when you use references in the same application. So here, notice now, by convention, when there's a pointer, we use PTR_sum in our parameter name. With a reference, you might do something like change that name to ref_sum just to make it clear it's a reference. And as a reference, instead of the asterisks, we use an ampersand. And what the ampersand says is this is a reference to a double, and here we bring in the reference to a double. Notice that in the function definition line, it's the same. And then notice how everything else gets easier, because inside of the function, we don't need to use a dereference operator. The C++ will recognize that this is a reference, and therefore it's going to put whatever you're putting into here into whatever this was actually pointing to originally. And then in the function call, again, we don't have any special symbology. So if you want to use references, just put it in the function prototype line in both the function prototype and the function definition, and C++ will take care of the rest. So references do basically the same thing as pointers, but they're a little bit easier. And here's another example. Here's a function that takes a reference to an int for rx and ry. And all we have to do is we pass an x and y, and it's actually not going to cin into rx. It's going to implicitly cin into whatever the address of the thing that was passed in, which will be this x and y. So this is just an easier way of doing the same thing that pointers did. And so when you do this, when we get line into our name, our age, we get line or cn into a reference, it's not going to go into the parameter. It's going to go into whatever was passed into the parameter. And so these will actually cn and get line into these variables that are declared in main. So there's some limitations with references. They're more convenient to use, but you can't have a reference to another reference, but you can have a pointer to a pointer. And a reference must be initialized when declared if it is not part of a function parameter list or if it is not a return value or a class member, and it is not possible to create a pointer to a reference or to create an array of references. So we still need pointers even though we have references, but references will make some things easier. So why do we need pointers? Well, first we're going to introduce arrays in the next chapter. In order to understand how arrays work, you kind of need to understand what pointers are. And in fact, later on, if you learn object-oriented programming, it really is helpful to really understand what's happening from a pointer perspective. And you're going to see, of course, pointers be used in references and other applications. And pointers are required in order to have your program perform dynamic memory allocation. So it's why we need to learn pointers. We can't avoid it. And later on, if you take a more advanced C++ course, you will use dynamic memory allocation. And dynamic memory allocation will basically give you a pointer when you're trying to create an object. So at this point, I would recommend that you complete the references demo. The Q class is a class that's useful for representing certain kinds of collections or lists. So the Q class is a first in, first out type of data structure, which means that the first thing you put in is the first thing that will pop out of the Q class. And so it can be used, for example, to represent a line of customers waiting at a bank teller. So in a sense, a Q class gives you the ability to build a line in your program. And you push data into the end of the line and pop data off the front of the line. And other than that, it kind of works as would be expected. So the way this might look is this. Here we have, of course, with all these classes that we're using, you have to have an include statement to include the library associated with the class. In this case, it's the Q class. And then here, in order to declare it, it's very similar to the vector class in that you have to specify what kind of thing will be in this queue. In this case, between the angle braces, we have an int, which means that it will be a queue of integer numbers. And here we can see that we're using the random function to randomly create some numbers and push those numbers onto this number line. And there's going to be about 100 of them. And then here we could have maybe we'd have a function show menu. We'd show and then we have a function of show line info, which will presumably just display what's in the queue. And then an add to line and a serve first. And so let's look at, and then in main, we say welcome to the C++ blank, and then, we create a bank line, and then presumably we'd be then calling these functions. So let's look at the add to line function in this program. Here we have it takes the queue by reference as a parameter. And so we're going to get a reference to this queue. And then what we're doing is we're asking the user to input who do we have at the end of the line. And so we're going to get they're going to input the name. And then we're going to use the push function. So the Q class has a push function. In the vector class, we used a pushback function, but in the Q, we use a push function. And the push function will place this item, this object, at the end of the queue. The serve first function takes a queue as a parameter. And here, it checks. And you notice that the Q class has this empty function. So if you say rline.empty, it will return true if the line is empty. And if the line is empty, we're just going to tell the user, hey, there's no one in line, you can have a coffee break. Otherwise, if it's not empty, that means there's someone in there. So now it will say next, now serving, and it will take the queue class has a front method. And what the front method does is allows you to look at what the first element is on the queue, but it doesn't actually remove it. It still leaves it in the queue. In order to remove something off the queue, you have to use the pop function. And the pop function will then remove that first person. So we have the ability to add items to the end with push, check to see if it's empty with empty, look at what's on the front with front, and then remove the first person in line on the queue with pop. And so that's basically the main functions you would use to use a queue and represent that kind of a data structure. There's also other functions. The size function returns the number of items. Empty tells you if it's empty. Front and push and pop, we saw how all those got used. So that's what we reviewed today. We reviewed references and the Q class. Thank you very much.